Hi guys, welcome back. We'll continue with the book Python for Data Analysis. This is the second part of the series, and in this video we're going to focus on the basics of Python, iPython, and also working with Jupyter Notebooks. If you want to follow along, feel free to subscribe to the channel, and let's dive right in. Let's learn about the Python language basics, iPython, and Jupyter Notebooks. If you want to follow along, you can head over to wesmckinney.com/book. The link is also in the description down below. We are going to cover the basics of working with the Python interpreter. We are also going to cover iPython and the iPython interpreter, and we are going to cover the Python language basics. Let's start working with the Python interpreter, and for that we're going to open up the terminal. On macOS we can open Spotlight and then type in terminal in order to open the terminal. And on Windows we can open up the Anaconda prompt as we did in the last video. Now, as we did before, we are going to activate our Conda environment, PyDataBook. And in order to open up our Python interpreter, we can simply type in Python. Within the Python interpreter, we can enter a command. For example, we can define a new variable a and set it to a value of 5 and press enter. And then we can go ahead and we can print out the value of a, which of course is 5. Now, in order to exit the terminal, we can type in exit with parentheses and press enter. And outside of the terminal, we can go ahead and, for example, execute a Python file by typing in Python. And then if we have a Python file, like for example, hello world.py, we can press enter, and this is going to execute our file. In this case, our Python file is simply going to print out hello world. Now, instead of using the regular Python interpreter, we can also use iPython. For that, we can type in iPython and press enter. And just as with the Python interpreter, our prompt is displayed, but we can see it is color-coded, and it, for instance, displays the line number that we have here. Now, from inside of iPython, we can go ahead and we can type in %run, followed by the name of our file, so in our case, helloworld.py, and this is also going to execute our code. Just as with a regular Python interpreter, we can also go ahead and define variables, for instance, and have a look at the different variables, but we can see that we have the line numbering here, and also whenever a value is returned, we can see it's highlighted in red, so we can directly see that this is an output. And iPython in general has a number of additional features compared to the regular Python interpreter, which makes it easier to work with. Let's have a look at another example. We can go ahead and we can import NumPy, and let's use NumPy to perform a calculation. We're going to cover that in detail a little bit later. Now, if you then go ahead and we type in data, we can see that we get an output, and the output is separated one value per line, so we have nicely formatted values. If we were to run this program in the regular Python interpreter, then we wouldn't have that color code here, and also the output wouldn't be formatted in this way. So iPython can be quite helpful for this. And again, to exit iPython, we can simply type in exit with parentheses, or we can press Ctrl D on macOS or Linux in order to exit the interpreter. Now, closely associated with iPython is Jupyter, and we can use Jupyter in order to work with Jupyter Notebooks, which is very useful if we want to combine plain text with code examples, for instance. So to start up Jupyter, we simply type in Jupyter Notebook and press enter. And this is going to open up a new tab in our browser. And here we can see a directory with different folders displayed. And from here we can then also create new Jupyter Notebooks. If the browser is not opened automatically, you can have a look at the terminal again, and here you can find the URL to the particular Jupyter notebook. Now, to get started, we can click on New, and then select Python 3, which is what we're going to work with, in order to create a new Jupyter notebook. And inside of this, we can enter just a Python command. So for example, we could say print hello world. And in order to run this, we simply press Shift and then Enter on the keyboard, and this is going to execute this line of code. We can also rename the Jupyter Notebook by clicking on the title here and then providing a name. Now, once we click on rename, that file will be renamed accordingly. Now, in addition to creating new Jupyter Notebook files, we can also download them from GitHub, for instance, and then open them inside of Jupyter. Now, in addition to creating new Jupyter Notebook files, we can also download them from GitHub, for instance, and then open them inside of Jupyter. For that, we can head over to the GitHub project of the book, And on the GitHub page here, we can go ahead and we can download that directory by selecting code and then downloading it as a zip. Now, once we downloaded that directory, we can then drag and drop it to the folder where we are actually working from in our terminal. And if we take a look at our Jupyter page again, we should be able to see it. So let's open this and let's have, for example, a look at one of the chapters here, so chapter 2. And here we can see the respective Jupyter file that we just downloaded. Now let's switch back to the terminal and let's open iPython again. And in addition to the cosmetical benefits of using iPython compared to the regular Python interpreter, there are some additional advantages. For example, if we have a variable in Apple and we set it to a value, for example 27, and let's say we have another variable, an example, which has a value of 42, we can go ahead and we can start typing any of those variable names and then press tab. And this is going to give us two options. So in this case, we have two variables that start with an. So when we press tab, we can see there are the options available to us, and then we can select the appropriate option here. iPython also supports introspection, which allows us to display some general information about an object. So let's say we have a list here, which has 3 different values, and this is stored in the variable b. Now if we type b question mark, we can see some information about it. So we see it's of type list, we see the length of the list, and we also see some explanation here in the docstring. Another useful example of using introspection is to have a look at the different functions available to us. So let's say we are going to first of all import NumPy, and then we want to take a look at different functions available to us. For that we can type in np for NumPy, then we're going to use the asterisk, the wildcard character, and then we can type in load, for instance, another asterisk, and then the question mark icon. And this way we can get an overview of all the different functions available to us as part of NumPy that have load inside of their name. So these are some of the benefits of using iPython as compared to the regular Python interpreter. Let's have an overview of the most important Python language basics. It's important to know that this is just a high-level overview of some of the most important features of Python. If you haven't worked with Python before and you want a more in-depth course on Python, there's a separate video series covering Python Crash Course, which is a great book for Python beginners. Let's first start out with the language semantics. In contrast to a lot of other programming languages, such as Java, JavaScript, or C#, for example, Python does not use curly braces to structure the code, but uses indentation instead. So we could either use tabs or spaces in order to indent our code and separate out the different blocks of code. Typically we would use spaces, and the structure is as follows. When we are starting a new block, for example here we have a for loop, we would add a colon at the end of it, and then we would indent the block itself. In this case here we have a for loop, and inside of that for loop we have an if-else statement, and that if-else statement is indented again because it's a separate block of code. If we want to add multiple statements in a single line, we can add a semicolon at the end of a statement. For example here we are assigning 3 different variables, and in order to add that to a single line we need to use a semicolon. Alternatively, if we didn't want to do that, then of course we would simply add each of those statements as a separate line item. And typically this approach here that we would have a separate line for each of the operations is a way to go. Adding multiple statements to a single line is generally discouraged. In Python, generally everything is an object, so every number, string, data structure, etc. exists in a Python interpreter as its own box and constitutes a Python object. And because of that, Python is very flexible, and even functions can be treated like any other object. We can of course also add comments to our code. Comments always start with a pound sign, and they are ignored by the Python interpreter, and that can be really helpful to give an explanation or some more context to our code. As an example, we have a for loop here, and inside of that for loop we have 3 separate comments, and these are used to comment out this part of code so it won't be executed. So if you want to provide more context, or if you want to simply make sure that part of the code is not executed, for example while we are debugging a piece of code, working with comments can be very helpful. Of course we also have functions in Python, and in order to call a function we would use parentheses and then pass 0 or more arguments to that function. As an example, we have a function f here that takes 3 different arguments, And we also have a function g that does not take any arguments. We can of course also associate functions with objects, in which case we call them methods. So here, for example, we have a method called SumMethod with 3 different arguments that is called on the object obj. And we can also work with both positional arguments, where the order is important, but also keyword arguments. And we're going to cover that in depth a little bit later. Now, when we are assigning a variable in Python, we are creating a reference to the object shown on the right-hand side of the equals sign. So for example, if we open up iPython and we define a list with 3 different values, we can then assign the variable a to b. And if we now have a look at b, we can see that we get back the original values here that we assigned to the variable a. So we created a reference from the variable b to the values of variable a. Now in some languages will lead to the values being copied. In Python they refer to the same object. So if we go ahead and we add a value to our list a, the value of 4 for instance, we can have a look at a and we can see we now have the value 4 added to it. But since a and b now refer to the same object, if we have a look at b, we can see that the number 4 has also been added to b. So if we look at that, we can see that both a and b refer to the same object, the list of values. Now, variables in Python do not have an inherent type associated with them. So a variable can refer to different types of objects simply by doing an assignment. So for instance, we could define a variable a which has a value of 5. And if we have a look at the type of a, we can see it's an integer. But then we could assign a to a different value, for example, the string foo. And if we now go ahead and we have another look at the type, we can see that the type now has changed and now is of type string instead. But while the type of the variable is inferred from the value assigned to it, Python is still a typed language. So if, for instance, we are trying to do this kind of operation, that we are adding the number 5 to the string 5, we're gonna get a type error because we are trying to do an invalid operation since an integer and a string cannot be added. Now, objects in Python can have both attributes, which are other Python objects stored inside the object, and methods, which are functions associated with the object. And if we want to get an overview of that, we can define a variable, for example, the variable a with a value of foo. And if we now go ahead and we press a dot and then tab inside of iPython, we can get an overview of all the different methods available to us. So in this case, these are different methods and attributes available for strings. Now, Python also supports duck typing, which means that we do not really care about the type of an object, but rather whether it has certain methods or behaviors. And this is referred to as duck typing after the saying, if it walks like a duck and quacks like a duck, then it is a duck. So for instance, if we have an object, we can verify that the object is iterable, so that we can loop over it if it implements the iterator protocol. So here's an example. We define a function is iterable, and we're going to try if we can call the iter function, passing the object as an argument. And if that does not work, we are going to raise a type error. And if we switch over to iPython, we can type in that function definition and then try this out. For example, we can call is iterable and pass a string to it. In this case, we would get back true because a string is iterable. We can loop over each individual character of our string. The same is the case if we pass in a list of values, because of course we can loop over each individual value inside of our list. But if we pass in an integer, for instance, we will get back the value false. And this works because many objects in Python have a so-called magic iter method, and this means they are iterable. We can also import modules in Python. A module is simply a file that ends with .py, so basically any Python file. And let's assume we have a Python file called sommodule.py, which for example defines a value for pi and then has 2 additional functions that are being used. Now if we save this file and we want to use it in a different program, then we could go ahead and inside of a separate file we could say that we want to import some module, and then we can work with the functions as well as with the variables included inside of our module. And instead of importing the entire module, we can also decide to import certain functions or variables from our module. And especially if those modules have a very long name, then we can shorten it. So we can provide an alias. For example, instead of some module, we're using the s keyword and then assigning the alias sm. And then we can simply call a function or refer to a variable inside of that module by referencing our alias. And we're going to use that a lot when we are working with NumPy or pandas, for instance. Of course, we can also use math in Python. We can use, for instance, binary math operations as well as comparisons. So for instance, we could go ahead and subtract 7 from 5, which gives us a value of -2. We can add numbers, both integer numbers, but also decimal numbers. And we can also make comparisons. So for example, we can check whether 5 is less than or equal to 2. And in this case, we would get the Boolean value false. So here's an overview of several binary operators available to us. We can do all the basic mathematical operations such as adding, subtracting, multiplying or dividing numbers. We can also do floor division, which means we are going to drop any fractional remainder. We can raise a to the power of b. And we can also do logical operations. So we can check whether a and b are both true. We can check whether a or b, either one is true. We can also check whether a or b is true but not both. And then we can check for comparison whether two values are not equal, whether they are less than or less or equal than, greater or equal than. And we can also check whether objects reference the same Python object or whether they refer to different Python objects. So in Python, a lot of objects such as lists or dictionaries are mutable. That means that the object or values that they contain can be modified. So let's hop inside of iPython and we can define a list of values. In this case, our list has a string, an integer and another list. And let's say that for the value at index 2, so the third value here, the list, that should be changed to a tuple with the values of 3 and 4. And now if you have a look at a list, we can see that indeed our list has been changed. So instead of containing a list, as we had originally, we now have a tuple that has been added. And this shows us that our list is mutable. But there are other objects like strings or tuples which are immutable. So as an example, if we have a tuple with 3 different values, 2 integer values and another tuple, and we then try to change the value at index 1, so it's the second position, to the string 4, we will actually get a type error. And here we can see that our tuple object does not support item assignment and is therefore immutable. Now these are some of the most important language semantics when it comes to Python. Python also has a small set of built-in types, so-called scalar types, for handling numerical data, strings, Boolean values, as well as dates and time. So let's have a look at the standard Python scalar types that exist. We have type none, which is equivalent to a null value in other programming languages. And important to note that only one instance of the none object exists. We have type string, which in contrast to some other programming languages is actually a scalar type. In some other programming languages we would work with individual characters. That's not the case in Python. We have type bytes, which contains raw binary data. We have type float to deal with floating point numbers. And we have type bool for Boolean values, true and false, and int for integer values. So when it comes to numbers, we have 2 primary types, which are type integer and type float. And type integer can store an arbitrarily large number. Now on the other hand, if we want to work with floating point numbers, we would use type float in Python. And we can define a float simply by adding the period decimal separator. We can also use a scientific notation in order to express very large or very small float values. Now if we try to divide 2 integer values that are not evenly divisible, then we always get back a floating point number. If we want to avoid that and we still want to get back an integer number, we can use floor division, in which case the remainder will be removed. So in this case, if we use floor division by dividing 3 by a value of 2, rather than getting back a value of 1.5, the remainder, so 0.5, will be dropped, and therefore we get back a value of 1. Now when it comes to strings, we can create a string by using single quotes or double quotes. And if we want to work with a multi-line string, Then we can use triple quotes, either by using 3 double quotes or 3 single quotes, and then ending our multi-line string with triple quotes again. Now, as we mentioned before, Python strings are also immutable. So if we define a string A, for example, this is a string, and then we try to change a value inside of that string. So here at index 10, to change a character to an F, we will get a type error because our string object does not support item assignment and is therefore immutable. So if we want to accomplish that, we can instead work with a replace method in order to replace a string with a new string. So that is a way how we can work around this. Now we can of course also work with Boolean values in Python. Those are written as true or false. And whenever we are working with a comparison or another conditional expression, this is going to evaluate to either true or false. And we can combine Boolean values by using the AND or keyword. So for instance, true and true is going to value to true, while false or true is going to result in true because one of the two values here has to be true when we use the OR keyword. And when we are working with numbers, false becomes 0 and true becomes 1. We can also use the keyword not in order to flip a Boolean value from true to false or vice versa. So for example, if A has a value of true and we say not A, we're saying not true, and therefore this will result in false. And the same is true if we want to say not false, this is going to result in true. Now we can also use typecasting in Python, which means we can change an object from one type to a different type. So as an example, if we have a string s that stores this value, we can say float s. So we're going to turn that string into a float value. And we could also turn that string into float and then turn it into an integer, in which case we would get a value of 3. As we mentioned before, none is Python's null value type, and none is also the common default value for function arguments. Now, whenever we want to work with dates or times, Python has a built-in datetime module that provides the datetime, date, and time types. So as an example, we can import datetime, date, and time from the datetime module. And then we can construct a new datetime object by passing, for example, a year, month, day, and a time to it. And if we want to then have a look at the individual day that has been specified, we get that back. So in this case, this would be the day. And we can also, for example, reference the minute, which would be a value of 30, which we have over here. Now, of course, we also have control flow in Python. So there are several built-in keywords for conditional logic, loops, and other standard control flow. So first of all, we have if, elif, and else statements. So if we want to check whether a certain condition is true, we can use the if statement. So here we have a value of x that is set to -5. And we want to check if x is less than 0, which is the case. Then this block of code will be executed. And if we have multiple conditions, we can chain this together. So instead of just using the if statement, we can use elif to check for other conditions, and else, which is going to cover all other conditions which have not been covered by if or elif statements before. So if any of the conditions are true, then this particular block of code will be executed inside the if, elif, or else statement. And if it's not true, then we're going to continue with the next elif statement, and all of the elif statements are not true, then we're going to default to the else statement, and that is a block of code that will be executed. If we want to iterate over a collection like a list or a tuple, we can use for loops. And to work with for loops, the structure would be the following. For a value in a collection, we're going to execute some block of code. So as an example, we have a list here called sequence, and we have a value of total. And then we can check for each value in the sequence. So we would loop over each individual entry inside of our list. We're going to check if that respective value is none. And if that's the case, we're going to continue, meaning we're going to skip the rest of the code and we're going to start again from the beginning of our for loop. And otherwise, we're going to increment total by the value. So if we jump into our Python interpreter, we can run this code and then we can have a look at total. In this case, we have a value of 12 because we looped over all the values inside of our list and ignored value none. So we add up 1, 2, 4, and 5. And this is going to give us a total value of 12. We can also use our for loop together with the break keyword. So in this case, using break, we would stop the iteration of our loop when a certain condition is met. So in this case here, we have a list of values and we're checking whether the variable value has a value of 5, and if that's the case, then we're going to break out of our loop and stop execution. So if we jump into iPython and we are going to execute our code, then we can have a look at the value of total until 5, and we can see that has a value of 13. So we continued looping through our list until we reached the value of 5, and then we stopped the execution of our code. And if we have a look at the values before, so we have 1, 2, 0, 4, and 6. If we add those up, we get to a value of 13. And important to note, the break keyword only terminates the innermost for loop. Any outer for loop will still continue to run. So in this case here, we have a nested for loop. So inside of this outer for loop, we have an inner for loop. And here we have the break statement. And this is only going to break us out of the inner for loop, not the outer for loop. Now we have another kind of loop that we can work with in Python, which is the while loop. The while loop does not run a certain number of types, such as the for loop. Instead, it checks for a specific condition and only executes the code until the condition evaluates to false, or when the loop is explicitly ended using the break keyword. So let's have a look at an example. Here we have a variable x that is set to 256 and a variable total set to 0. And we are then using a while loop, which has the condition x greater 0. So we are going to run our while loop while x is greater than 0. And if the total value is greater than 500, we're going to break out of our code. Otherwise, we're going to add x to our value of total. And then we're going to use floor division to divide x by 2. So if we run our program and we then have a look at total, we can see that total ends up with a value of 504. And at that point, we basically stopped because 504 is greater than 500, and therefore this condition was met and we are breaking out of our loop. We also have the parse keyword in Python, which is basically our do nothing statement, and that can be used in blocks where no action is to be taken. So for instance, if we have an if statement here and we have an elif branch, and we are still going to add some code inside of our elif statement, so we added a comment here that we need to do something, we can use the parse keyword in order to make sure that our code is valid. In this case, the parse statement just means that if we encounter this branch of the elif statement and that evaluates to true, then we're not going to do anything because we're using the parse statement. We can also use the range function inside of Python, and that generates a sequence of evenly spaced integers. So for example, we can have a range of 10, or we can specify a starting and an ending value, a range from value 0 to 10. And we can also go ahead and turn that range into a list. So if we're going to say we have a range from 0 to 9, which range 10 refers to, we can turn that into a list. And then we get back a list with all those values that are covered inside of that range. So in this case, the values from 0 all the way up to, but not including 10. We can also optionally define a start, stop, and step value. So in this case, we have a start value of 0, a stop value of 20, and a step value of 2. And if we turn that into a list, we can see that we go in increments of 2 from 0 all the way up to, but not including the end value of 20. So we go from 0 to 18. And these are some of the most important Python basics that we're going to use going forward. We covered the basics of programming in Python. We also had a look at the iPython shell and working with Jupyter Notebooks. In the next video, we're going to cover built-in data structures in Python, and we're also going to focus on functions and working with files. If you want to follow along, feel free to subscribe to the channel to not miss any videos, and see you guys in the next video.